So on to part 2 of using Jupyter Notebooks. Here we are in a Jupyter Notebook, but you will notice that it looks slightly different. This is not in JuliaBox. I am reading this using iJulia, and it looks almost the same, but there are some small differences up here. When you get inside the Jupyter Notebook itself, it's entirely identical. So this is the notebook on using JuliaBox, and a lot of this we've done already. So first thing, you log into the JuliaBox website, and of course this is what you see. In fact, you don't quite just see this because we're now inside Untitled folder, but if you were in the home directory you would see tutorial. And if you start your own JuliaBox notebook, then of course this is what you see. At the moment this is still untitled, and then you can start entering. So let's do that, and we can see that this is now entry number 3 of a code box, and 1 plus 1 is 2, and a number of other calculations can be done. We only see the last one, we don't see this calculation. So the output that is reported for a given code cell is just the very last calculation that was done. There's a reminder of the elementary arithmetic operators, and there's a reminder that you should use parentheses if there's any possibility that your expression is ambiguous. This is a reminder of how you name and save open JuliaBox notebooks. So all of that we've done previously. Let me just add a few comments about Julia as a language. The first thing to realize is that Julia looks exactly like an interpreted language. Strictly speaking, it's not quite an interpreted language, but it looks exactly like one. And this is because the moment you enter a piece of code, it gets executed. So that means it's very like Python and MATLAB, who are also interpreted languages. There's a large body of computer code sitting and waiting and ready to execute a very wide range of commands. Your operating system is not like that. It has a limited set of commands it can execute. That's why the interpreter is there, so that you can do a lot more. That makes it relatively slow. On the other hand, if you want to use the fast speed of the operating system, then you use a compiled language. The code is first compiled just using operating system capacities, and then it runs as a freestanding program, and you don't interact with it while it's running at all. Second thing I want to say is that if you use a notebook such as we are, that's actually a luxury. We don't execute just one line at a time. We can put lots of lines in a single cell and then execute them all at once. If you're working in the command line, you can really only do one line at a time, with some provisos that are not that important. Finally, of course, JuliaBox is a wonderful environment, and the Jupyter notebooks are a superb resource for us to be playing with Julia. But if you're actually serious about running Julia programs, then your Julia project is likely to consist of files, and many files indeed. So Julia itself is actually hundreds of files that contain many thousands of code. And most of them are written in the Julia language, although a few are written in C and even a few other ones in other languages. Finally, when you start up Julia, you actually have a package, the base package, and that gets made available to you and you run it. But it doesn't have that much capacity, and there are many things that you would like to do that are not in the base package. And in fact, we will cover that in this course starting in week 3 and going on into week 4 as well. For those of you who want to use iJulia on your local computer, here is a set of steps that will work, at least on some systems, but we have a fuller explanation and illustration of how to use iJulia in a separate lecture later on in the course. So that's the end of Jupyter Notebook.